Additive synthesis is one of the oldest synthesis formats in theory. Although subtractive synthesis was first to gain commercial appeal, additive existed in the laboratories and in some electromechanical instruments such as the Hammond organ and teleharmonium. However, it took digital synthesis arriving on the scene to finally give additive its day. Like most other forms of synthesis, additive synthesis begins with a sound. In the case of most additive synthesizers, this sound is a pure sine wave. Additive synthesis utilizes a large number of sine waves at any given point. These sine waves are referred to as partials. By combining various partials at specific frequencies, we can create desired sounds. So how do we know which frequencies to set our partials to? It all relates to overtones in the harmonic series. The harmonic series is a naturally occurring pattern of overtones that exists in any given sound. Take a piano. When A440 is struck, 440 Hz is not the only frequency that is heard. A wealth of higher order frequencies are also heard. These frequencies are all multiples of the fundamental frequency. In the case of A440, 440 Hz is the fundamental frequency. The frequencies of the higher order harmonics can be calculated by multiplying their harmonic number by the fundamental frequency. So if we start with 440 Hz as our fundamental, or first harmonic, the second harmonic is 880 Hz, while the third is 1320 Hz, and so on. The frequency of the individual harmonics is only one step of the equation. The individual harmonics level and phase relationships must also be taken into consideration. Some sounds will only have odd harmonics, while others might only have even harmonics or a combination of the two. In regards to synthesis, let's look at the classic sawtooth wave. The sawtooth wave contains all upper harmonics, both even and odd. The levels of these harmonics are inversely proportionate to their harmonic number. This means that the second harmonic is half the amplitude of the fundamental, while the third harmonic is 1/3 the amplitude, and so on. Utilizing the harmonic series, we can use additive synthesis to build sound from its most basic building blocks, individual sine waves. By adjusting the frequencies, levels, and phase relationships, we can create any number of sounds. We can also use envelope generators and LFOs to modulate certain aspects of our sound like partial level and frequency to make extremely interesting sounds. Additive synthesis is truly a powerful synthesis technique that offers the user endless possibilities. The following video will go through the parameters of a modern additive synthesizer and demonstrate how to program sound on this extremely powerful synthesis format.